To the seventh column, I would write program test subroutine, and we will emphasize on the strong typing in the Fortran 90 style. This is program T subroutine. Right. So let's define variables real x, y, and then I define real calculation 1, calculation 2. Right. So having these things, we define calculation 1. Right. To be very particular and identify clearly that CAL, L and 1, they should be distinct. Right. I write here first calculation x squared minus y squared. This is first calculation, and calculation 2 is equal to x plus y, and that's it. X plus y. And we can print that one. See, print calculation 1 equal to calculation 1, and print that is calculation 2 equal to calculation 2 before printing. Right? I have written just one program, and then I will introduce the subroutine structure. So how do we write that in subroutine style? So this is a correct program. Let's see whether it is correct or not. We have to test it. So let's save the program. Okay. Let me change the sharing option. So sharing everything from the screen. Let's save the program. Right, in the G directory, we have G77 compiler folder, and we have there in the bin folder. So file type, Fortran source file, and tsub.for. Right. So it has been rightfully saved, and the commands have been colored. Right. Now we will access the same directory from here. Okay. We are here. So T77 compilation command tsubroutine.for -o, and I write tsub.exe. I'm really surprised many times that whenever I compile the first program in a new session, it takes so much time. But in the next go, it does not take so much time, right? So tsub.exe. So we have got very, very strange values because we have not provided any values for x and y, right? So strange error. So if we look in the main program, we have not provided any values for x and y. So with some values from the memory, right? So it has taken some values of x and y and performed the calculation 1, and in calculation 2, it has provided some. It has also taken the garbage values from the memory and perform the calculation. So let's first define x equal to 0 and y equal to 0. So to rightfully get the 0 value. So again compile, and now see within a fraction of a second it has compiled and run. So we have got 0 values. Now let's get get it transformed to a subroutine structure. So everything that I have written here I would copy it as such, right? From declaration to calculation part, right? So now they are no more here. And now I write this calculation in subroutine form because my objective is to use this many times. So I start here with the keyword subroutine, and I give it a name that it is a calculation, and I provide here variables x, y, calculation 1, calculation 2, right? So inputs and outputs. And here the structure goes with the real x, y, and real calculation 1, calculation 2. We don't have to write here the values of x and y because they will be provided from the main program, right? And after that, I will write here the reserved keyword for the subroutine structure return. And then here we will write end subroutine calculation, right? So subroutine name is not a variable. The variable names are calculation 1 and calculation 2. So now in the main program, let's define some variables, right? So for the time being, let's say A, B. These are for input variables, right? And for output variables, I define here C, D, right? Out 1, out 2, right? So now let's read some values of A and B. So before that, I prompt the user to enter values of A and B, right? Two real values, A and B. And our objective is to read them in one line. So I provide AB, right? So spaces, commas, line spacing, they will separate the two values A and B. They will be identified as distinct values. And now let's get to the calculation. So for calculation, we'll call the subroutine. With A and B values, perform the calculation which is grouped in, which is defined in subroutine structure. So I write call calculation, right? Subroutine. So arguments must be consistent. A, B, out 1, out 2, right? So input variables A, B, and output variables out 1, out 2. So with the word call and calling the subroutine with variables A, B as input, outputs in output 1, output 2. So now in the in the output, printing the output, I would write with the variables of main program, right? So out 1, and here it should be out 2 because these are the variables of main program, right? So subroutine and function variables cannot be printed from the main program structure. However, you can add print statements within the subroutine. There is absolutely no problem. Right? And just to make it consistent, I write here out 2. Right? So I'm calling a subroutine in the main program, right? So see the structure of the consistency of the variables, right? So their order must be intact. That is the only condition to use a subroutine. I have saved the program. Now we will compile the main program. It has a subroutine to perform two calculations. So compilation command. Right. So compilation has been successful. Now the subroutine. Enter values of A and B 0, 0. So we have got output 0, 0. So let's Let's test it again. For variables 1, -1, so we have got 1 - 1, 0, 0, right? Test. So with values 1 and 0, 1 for A and 0 for B, right? So line spacing. Fortran will wait for 2 values from the user, right? Very nice. So it has qualified all the tests that we have given to it, right? So that's how we use. Let's have a look at the main program and subroutine once again, right? So my objective was to provide 2 values as input, right? And perform a calculation, which is defined here as calculation 1 and calculation 2, right? I have stored this calculation part in a subroutine structure where I have provided the input and output arguments, right, in parentheses. And to identify this calculation, I have given a name to the subroutine CALC, right? So now in the main program, I define the input and output variables, right, of the main program, and then provide the values in the structure of, well, in the subroutine, and I call the subroutine with the keyword call, and with the subroutine name. So the calculation will be performed and the values would be stored in the respective variables and the output would be generated, right? So from subroutine, it means return everything, right?